All right, so what we're going to be going over is 4.1, which is called winner winner, and it's all about rational functions, rational expressions, and rational equations. Okay, so what rational just means, it just means it's a fraction. Okay, that's all we're thinking. So today, our goal is to understand the behavior of this 1 over x for very large values of x and what happens right next to 0, and then be able to describe the features of it using appropriate notation. And then the questions that we're going to be able to answer is, how can winning the lottery help us think about this? And what features of 1 over x mathematically, what is interesting about this? So here is our context. So one of the most interesting functions in math is f of x is equal to 1 over x, because it brings up some mathematical mind benders. In this task, we will use a story, context, and representation like tables and graphs to understand this important function. Let's begin by thinking about the interval of 1 to infinity. Remember, this is in an interval, which means it includes 1. And then infinity also always gets a parenthesis, because remember, infinity is not like an actual real number that I can show you, right? So imagine that you won the lottery and were given one big pot of money. Of course, you would want to share that money with friends and family. If you split the money evenly between yourself and one friend, what would each person's share of money be? All right. So give me some answers in the chat. Put some answers on the thing. Will you do that? I'm just going to grab attendance. Yeah, right? Exactly. So it would be half. You would get half of the money and your friend would get half of the money. So exactly, it's half. Someone said 50%, even better, right? Actually, fractions or decimals, it's the same. I don't know why I said even better. Silly. Okay, so if 3 people share that money, what would be the person's share? What would yeah, so now we're at a third. You guys all good so far? So I want you to think about the pot of money. You got the pot of money, right? And then you decided, okay, well, I'm going to be generous and I'm going to share it with some of my buddies. And then I'm going to share it with more of my buddies. What is happening to your share of the pot? What is happening to your share of the pot? Yeah, it's getting smaller. Is the amount of money that you first got, is it getting smaller? No, the amount of your share is getting smaller. Does that make sense? Right? Okay, so just keep this in mind. So you can kind of imagine what the graph is doing right now. That's what I want you to think about. So I want you to model this situation with a table, with an equation and a graph. So just pretend that it's 1, just so that it makes the most sense, right? So if there's one person, how big is that person's share? If there's 2 people, what about 3 people? What about 4 people? What about 5 people? What about 100 people? Okay. Like, how is this growing? And then they wanted you to make a table, an equation, and a graph. So here's your graph. Here's your table. Here's where you want to put your equation. So go ahead and do a little bit of this so we can move forward. I'll pause it right here. All right. So you guys already told me this. This was 1. If it's just me, myself, and I get the whole thing, right? If it's 2, then it's 1/2. If it's 3, then it's 1/3. If it's 4, then it's 1/4. Do you guys all see how this is working? Strunton, this seems silly. Yeah, right? So if I graph this over here, right, it would look like this. 1 would be 1. So 1 would be 1. 2 would be 1/2. 2 would be 1/2. 3 would be 1/3, which is about 0.33333. So that's like a little higher. I don't know. 4 would be 0.25. So that would be right here. You guys all see what's happening? Do you see this curve that's happening here? Will I ever get zero? Will I ever get to zero? Can I put a number here, right? And then this would equal to zero. That's my question. Will I ever share with so many people that I'll get $0, 0 cents, 0 shares? What do you guys think? Perfect. The answer is no, right? Because even if my pizza, if you want to think about pizza, even if I shared my Costco sized pizza with all of you, we'd all get some thin little slice. And let's just say we decided, let's cut our slices in half and share it with the class next door, right? I would still have a really skinny slice of pizza. I wouldn't have very much, right? But it wouldn't go down to 0, right? So the answer here is going to be no. There's no number here that would ever make me have 0 shares, right? Unless someone stole, and that's not what we're talking about here. So just keep that in mind. Okay, very good. So our equation here is just what we've been studying, which would be 1 over x, right? Where x is the number of people. Got it? Okay, let's continue on really quick. So it says, just in case you didn't think about the really big numbers in your model, how much of the prize would you get if 1,000 people shared, 100,000 people, and 100 million people shared, right? So you all know the answer to that. So use mathematical notation to describe the behavior as this function approaches infinity, right? As it goes towards infinity, so let me look at my last little slide. As I start graphing the bigger numbers all the way out here, you told me that I won't ever get to 0. But if you think about my share with 100 million people, it'd be really small. So what is happening as I share with more and more people? How could you put that? As I share with more and more people, what is happening? What do you guys think? Yeah, the amount is decreasing for sure. And my share is going down, right? My piece of pizza is getting skinnier and skinnier and skinnier and skinnier. And pretty soon I pick it up and it doesn't even look like a piece of pizza. It looks like a straw. It's so skinny, right? Okay, so exactly. So use mathematical notation to describe the behavior of this function. So this is something that I want you guys to focus a little bit harder on this semester, is looking at mathematical notation. So we talked about it before and we said something like this. So as x approaches infinity, oh, let me get this guy in here. Let's go here. And I can't remember. I don't know how to do an arrow in math there. So I'm just going to do this. Just pretend that's a really good looking arrow. And then as x approaches infinity, which this doesn't like infinity. So let me go over here really quick. Yeah, but it doesn't combine itself to make an arrow. That's my little weirdo thing here. Okay, so as x approaches infinity, what's happening to my function? So f of x, where's f of x going? It's going towards where? What number? Oh, how come it did it for that, but it didn't do it for that? What? Oh, probably because it's x. It did it, Sam. It did it. I know. I am challenged, Sam. It's okay. Where's f of x going towards? You said it's getting smaller. Very good. It's headed towards 0. But you told me it doesn't touch 0. But can something head towards 0? Everyone's like, yeah, absolutely. Okay. So the way I like to think about this, and I've described this before to you, is I want you to pretend, and maybe I'll Google the picture. So ocean, sky, horizon. Photo. Let's see if I can find a good one. Okay, this is a pretty good one. All right. So I want you to concentrate on this. I want you to pretend that here I am. I'm standing on the beach. You guys all standing on the beach with me? And we're looking out to this ocean here. Do you guys all see the ocean out here? So what this looks like all the way out there, all the way where my tiny little finger is, it looks like the sky is touching the ocean, right? but we know that the sky is up here and the ocean's down here. So technically they're not touching. And some of you are like, but Ms. Johnson, the sky is air and air is touching the ocean. I'm not going there. I'm just going with the idea that all the way out there, it looks like the sky is touching the ocean. But when I get over there, like, let's say we're in a boat and we're right there. I'm going to be like, no, sky up there, ocean down here, they're not touching, right? So that's the same kind of idea that's happening here. As X goes really, 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 really big, my function gets really, really small, but it's not touching it. It's approaching it, but not touching it. Does that make sense? All right. So mathematical notation, this is what I want to see. And I'll say this in English so that you guys can all know what this means. As X approaches infinity, and another way you can say this is gets really big, your function, so f of X approaches 0. Okay, but it doesn't touch it. It doesn't equal it, and that's important. And that's what we were talking about last time, was an asymptote. Do you guys all remember this word asymptote? So just give me a second. It says, now let's look at the interval from 0 to 1 and consider a new way to think about splitting the prize money. So imagine that you want each person's share to be half of the prize. How many people could share this prize? So, oh, how did I type infinity on the keyboard? Good question. I didn't. I went to Desmos, and if you type infinity, and if I hit this Y, it's going to turn into the symbol. Boop. And then I copied it from here. Because for some reason in here, this works differently than in here. What? Here too? Am I just infinity? It does. I don't know why. I did the extra step. Apparently, I am not the expert today. So for some reason, it didn't work the first time. I'll have to go back and check. Okay, so if I wanted each person's share to be half of the prize money, how many people could share the prize? Yeah, exactly, 2, right? If I wanted it to be a third, how many people would share? Very good, it would be 3. Okay, now here's a weird question. Are you ready? So let's say, if I wanted it to be half, then this would be 2. If I wanted it to be a third, then it would be 3. So here's, if I wanted half the share, then I would go 2. If I wanted it to be a third, which looks like it's here-ish, then I would go here. Good. Right. And then if we continued, if I wanted it to be a 10th of the share, then it would be 10 people, yeah. Which looks really weird. It's like all the way up here, maybe. So do you all see this curve happening here? Right. Very good. Very, very good. Okay, let's move on. Okay, what do you notice when you compare the two models that you have written? What do you notice about this one here? And where are you here? Yeah, here. So 1 over X here and this one here. What was the equation for this one? Someone says, anybody know the equation for this one? I skipped it. 1/2 would be 2, 1/3 would be 3. The equation of this would be what? Yeah, 1 over X. Very good. Thank you. Oops. Let's put this in math. Oh, that's yucky. I don't like it. There you go. Yeah, it's also 1 over X, which doesn't equal to X, but it's 1 over X, right? And when you flip a fraction, that's why the 2 pops up. So some of you said, oh, it's this exact same. Exactly. So now let's put this all together. So for this function here, create a table of values that includes negative input values. Now, negative input values don't make sense for that, but let's just pretend it does, just for the sake of this. So if I put negative, I don't know, pick a number, -1, sure. And then negative, this would be -1, correct? If I put -2 here, this would be negative 1/2, right? If I put negative 10 here, this would be negative 1/10, right? So how does this compare to our other graph, which I think was here? How does this compare to this? How does this compare to this? Yeah, it's the same, but it's flipped. Very good. So you guys are actually thinking of what the graph looks like, which is awesome. Okay, that is exactly what I want you to think. So it would almost like, think about this guy here, and I want you to think about your negative values. Someone said it would be flipped. So think about them kind of like modeling that same behavior here. You guys all see my little pretend curve? Yeah, they're reflected. Very good. Good words, guys. Strong work. Okay, so I actually want to graph 1/x, and some of you are like, Ms. Johnson, I could just graph it right here. Absolutely. Let's graph it. Well, what does this thing look like? So this is that first branch. These are called branches. This is the first branch that we looked at, right? And then this is the branch that you guys said, oh, Ms. Johnson, it's reflected, it's flipped. Exactly. Very, very good. So let's put some stuff there. So any questions about this? So this is, if I look at this, this is me having my own money. And then this is me sharing, more sharing. I'm doing more sharing. Does it ever get to 0? Everyone says no. No, it does not get to 0. All right. Well, what about this side, Ms. Johnson? What if I plug in 0? What happens if you put 0 right here, guys? What if I put 1/0? What happens when I put 1/0? What does your calculator say? I'm not going to hit 0. Yeah, it's not defined. Very good. It's undefined. Okay. So why is this undefined? Because if you think about our context, 1 is how many shares would a person get? 0 is how many people are sharing that share. Right? So if you have 0 shares, how many shares does each person get? Doesn't make sense. Right? Think about our pizza analogy. I have a pizza and I'm going to share it with 0 people. How many people are going to eat the pizza? 0. So how much pizza does each person get? Well, you're like, wait a second. There's 0 people. How many shares does each person get? I don't know why, but it kind of reminded me of that one. It was like a logic puzzle. Have you guys ever heard this one? Like, like a plane crashes on the border of Canada and the United States. Where do they bury the survivors? Have you guys ever heard this one? Yeah. What's the answer? I'll say it again. A plane crashes on the border of the United States and Canada. Where do they bury the survivors? Yeah, you don't bury survivors. They're alive. Very good. Very good. So here, I know. So people are trying to bury people. We don't bury people that are alive. Just FYI, just kidding. So same thing goes here. If you're asking how many people are going to share the lottery with 0 people, how many shares do you get? And you should be saying, that doesn't make sense, Ms. Johnson. That doesn't make sense. Exactly. So just keep that in mind. So as we get closer and closer to 0, this number gets bigger and bigger and bigger and bigger, right? Bigger and bigger, or in the negative way too. Okay. Almost done here, guys. So describe the features of 1/x include domain, range, intervals that increase, decrease, x and y, intercepts, and behavior, any max or mins. Okay, so this is where you all know part of it, but not all of it. And I want to make sure that we know all of it. Okay, domain. Domain, again, is going to be, you look from left to right, and you're looking for any numbers that you can't have. So what numbers did we just talk about that we can't plug in? Yeah. So we're going to say all real numbers except 0. Okay. The fancy way of saying this is, you could do it. Let's see. You could go with, okay, so fancy way, ready? So negative infinity, comma, 0. And I'm going to put I'm going to put parentheses around these guys. Ms. Johnson, why are you putting parentheses again? So parentheses always goes around infinity, period. The reason why we're putting a parenthesis around 0 is because we don't want to include 0. And then we go from 0 to infinity. Okay, that is the fancy way of saying it. Sometimes we put a U here and I can't figure out how to put a U. Union. It doesn't do it. Like put a U. I'm not going to put a plus because that's not correct either. Okay. Okay. The next one, range. Range is the same thing, except for instead of looking from left to right, we're looking from bottom to top. Are there any numbers here that we will never get? Yeah, 0 again, Miss Johnson. Exactly. So I'm going to copy this again. Here, 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 done. Everybody okay with this? Yeah. Okay. So the next one is intervals of increase. Increasing. So increasing means when I travel from left to right, my function is going up. Oh no, I'm going down. Okay, so that's not going up. That's actually going down. Okay. So let's get on this French. If I travel from left to right, which way is my arrow going? One says down. Oh, so I don't have any. So none. And so decreasing, it's decreasing on this whole entire thing. So it's going to look again like this. Ms. Johnson. It's that again. Yeah. See, if you look at my arrow very slightly, it's slightly going down. It's from here, it's going down a lot actually. And then here it's just going down slowly. Okay, next one. Increase X and Y intercepts. Does this ever hit your X and your Y intercept? X and Y axis. Everyone says no. So I'm going to write intercepts none. Ms. Johnson, you can have a function that has no intercepts. Yeah, right? That looks weird. Yeah, it's none. Okay, end behavior. This is what we were talking about before. Do you remember? Do you remember our end behavior? So we would say something like this. I know the bell is going to ring very soon, so I'm trying to hurry up. So as X goes towards infinity, f of X is going where? Where's f of X going to the right? Where's he going? Everyone says what? He's going towards what? Yeah, he's going towards 0. Right? He's getting closer and closer to 0, but he's never touching it. Yeah. Does that make sense? So no, not infinity. It's going towards 0. So if I drag this all the way out here, like, let me drag this all the way out here. See how this number, your Y number, is getting closer and closer to 0? Again, it's never touching it, but it's getting closer. Okay, let's do the left side. As X is going towards negative infinity, where is your Y going? Yeah, it's also going towards 0. Cool. So, Ms. Johnson, what else? What about the maximums? So technically it doesn't have a maximum because it goes up forever and it goes down forever. And the last thing I want to talk about is the fact that this is an odd function. So the fact that this is an odd function goes like this. Now, when I go to the right, so many, like I'll say 5 for now. And I look at the value of 5. Oops. Is this 5? I can't get to 5. There it is at 0.2. And then I go in the negative direction and I look at my 5, my negative 5. Come on, buddy. Oh, there it is. It's at negative 0.2, which there it is. Do you see how when I go right, it goes up 0.2. When I go left, it goes down 0.2. It's opposite of each other. So the definition of an odd function is f of x equals negative f of x. Ms. Johnson, what does that mean? If this is true, then it's an odd function. Okay. Oops, sorry, I forgot a negative. If this is true, then it's an odd function. And this is what you guys said. I said, hey, what happens with these negatives? And you all said, oh, it's reflected, it's flipped. That's what you actually were describing. When I go right 1, it goes up 1. When I go left 1, it goes down 1. See, right 1, up 1, left 1, it goes down 1. Okay, so this is what an odd function is. So let me graph another function and you guys tell me. So let's take x squared, which you guys are very familiar with. If I plug in this number here, say 2, I get positive 4. And I plug in negative 2 and I get positive 4. That's not opposite, Miss Johnson. Those are the same. So this would be considered an even function. An even function. Does that make sense? So just a little definition. I think you were supposed to learn that a long time ago, but not a big deal that you don't remember. Okay, so let me stop recording.